And now this comes to the question, all was what we have learned about the LED, and now is LED really the game changer for the industry? And with me in the studio and today, accompanying the discussion here, I'm very glad to have Holly Steedman here, business development at ITL Integration Technology, Andreas Koch, head of printing in ink, at Zellog Melin. Hello, happy warm welcome. Hello. And then Dr. Volker Linzer, he is at the product management Europe for UV packaging inks at Sun Chemicals. Hello and happy warm welcome. And finally, last but not least, Joachim Kranz, he is head of sheet fed at IST Metz. Yeah, so coming to the first question, literally, LED replaced in the lighting industry to the high efficiency, the LEDs, the normal lighting or the normal lamps. Will that same be happening within our industry, Andreas?
I think you are right, but I think you quite can't compare the two areas. If you talk about the lighting industry, lighting technology, LED almost offers just advantages to the consumer. So the transition was very fast. If you look at the existing UV technology, UV lamps, it covers still a huge range of application and it's working excellent. So the motivation at the moment for printers to change immediately to LED is not the case. So there will be a slower transition from UV to LED. And this will be also very much depending on how fast LED will develop further and how fast the ink manufacturer can adapt to this new technology.
Mm-hmm. What do you think?
Yeah, I would absolutely agree. This technology offers sustainability advantages over the current lamp systems. However, there is many industries to cover, and there is limitations in the spectrum of LED lamps versus the current lamp systems, and this needs to be adapted to. If it is coming from the lamp manufacturers or chip manufacturers or coming from us, from the industry, we have to all adapt to integrate these systems and replace the old systems.
Mm-hmm. So what are really the advantages in using LED technology, Holly?
Well, from my point of view, you see, I've already discussed in my presentation before some of the advantages, the technical aspects, printing on heat-sensitive substrates, for example, is a great advantage. Also, integration is a great advantage. Also, the systems themselves, the LED heads tend to be a lot smaller compared to a standard UV system. So that is also making the integration a lot simpler, and also possibilities with retrofitting also there. That's from my side, I see the big advantages.
And from an IST side, Joachim?
So a lot of our customers who are going into the LED business appreciate that green thought behind it, meaning that it's ozone-free and even more important, mercury-free technology on the one hand, and in addition to that, if you really do it right, you can save a lot of energy compared to a lamp solution, because you can immediately switch it on and off all the time, even between the sheets of an offset sheet fed machine.
Mm-hmm. So are there any limitations when you're using LED technology?
The matter of fact is yes, there are limitations when it comes to food packaging applications. For example, there is the challenge of migration. So there are limitations with LED technology, and also some power applications may be limited to that. And last not least, an important one is that the bandwidth of available inks and coatings and so on is a kind of more limited in the LED area, specifically when it comes to special effects like metallic colors and things like that. Then we have a limited availability of chemistry.
Andreas, do you agree in this?
I agree, and I think also a limitation in printing speed. So if you have a very high printing speed, especially, Zellung Mehling is very dominant in this cup printing, rigid plastic segment, and there are machines running 720 cups per minute. And if you go in this range of speed, it's a big challenge to get this cured with LED technology.
And on the other side, are there any applications that can only be realized with LED? Volker?
Yes, there is the downside of the LED system is the bandwidth of available wavelength. And the LED offers just wavelengths above 365 nanometers today. But this disadvantage is also an advantage in the situations where you have to cure thicker film thicknesses. So for repair work or everybody knows in dental areas this technology is used. But also when you have applying thicker film thickness for inkjet applications or screen applications.
Okay, and from an ITL perspective, are there just applications using LEDs?
Yeah, we've seen applications where the water-cooled systems are integrated in places where it's difficult to integrate standard systems because of the air movement. This is a great advantage, and this then opens up opportunities with adhesives in clean room environments, for example, that are difficult to do with a system where there's air movement. So that is made possible through LED water-cooled systems.
Okay, and what is the lifetime of such an LED system within integration technology?
We say we got from two sides. We say it's over 20,000 hours, but also from our point of view, we also have a 5-year warranty on our XT8 technology chips.
Okay.
Yeah, so I mean, 20,000 hours is a long time. It's especially when you're only on for a few seconds. So. From that point of view, they're very robust systems. I think it's the same with IST, the systems. We have similar specifications.
Yeah, in fact, we are also having this reference number of 20,000 hours. And as you saw in the previous presentation by Thilo, we have in our lab at IST our high-end device, the Louvre 3, and this is now running for about 26,000 hours, and it's still in an excellent shape. And we are trying to simulate a rough environment, so we don't let it run just away. It's being cold and warm and on and off and all that. So I think the 20,000 hours might be even the lower end even.
Yeah.
And what happens if you have to repair it? Is it easy to repair?
Let's put it like that. On our Louvre 3, we have designed it in a way that it's a modular design that you can exchange specifically the LED modules, the individuals. However, it requires knowledge, it requires specific training. It cannot be just done easily. But if we would provide a proper training to a technician, maybe even with a certificate, then it should be possible.
Thank you very much. How is it with integration technology? How is the service and the repair?
So it's similar. It's also possible to change the modules on our system. Also, other components can be changed. For example, the glass that covers the LED modules themselves. This could be damaged in production, for example, something physically hitting that glass. So the lamps themselves are, you could almost say it's relatively sustainable from a point of view that you can repair them, and a lot of that can also be repaired locally on site. So there's no sending back and customer having downtime. So this is a real advantage, I think, for industrial applications.
And the service concept behind is also then related to this whole repair and modular concept.
Yes, exactly. Obviously, from our point of view, obviously these lamps are in industrial environments. They need to be able to be repaired easily. Yeah, it's downtime is a big issue. Obviously, you could have a spare lamp system, but that's not always practical for all of customers. So this is a real key point, I think.
Okay, okay. When it comes to LEDs, it's always being said that they are so efficient compared to UV lamps. Is that really the case?
Well, I think that goes to the point about how it's only on for a few seconds or less than a second, depending on how long you're curing. It's with the standard UV system, it's you're always on. So there you're actually where you have the effect of the cost effect there.
Okay. And from an IST perspective, do we
Yeah,
agree with this?
I think that's exactly as you already mentioned. It can be really efficient if in certain workflows. And yesterday we have a customer of ours who is using that system in his sheet fed machine, and he's saying that he is saving energy on the one hand because, well, if you compared to UV, because whenever there is a washing cycle or something like that, or a short break in a lamp, you have it in a standby mode so that it consumes energy. Versus if you have an LED, it's off immediately, and that can save a lot of time. And also, he had short run jobs, a lot of breaks in between, and then it switched off and saving power at that time.
Great to hear. What is the needed space for such an LED system? Can it be retrofitted or?
Let's put it like that. We at IST have a lot of experience with retrofitting existing machines with lamp solutions. And an LED solution, the LUV 3, is more compact because it doesn't need the air suction solution. It only is water cooled. So in other words, it's a more compact solution. In other words, yes, it's almost always possible to retrofit a machine with a UV solution.
Okay, I would think that's the same with the integration
Yeah,
technology.
it's the same. If there's a UV system that's been there before, then obviously to change that for an LED system is simpler and will take up less space.
Okay, okay. All around the media is currently being talked about UVC. Especially when it comes to air sterilization. Are there any UVC LEDs already on the market, and do we use them?
There are available. However, at the moment, it's a situation where the output versus the price doesn't fit with the reality of going into the market with such a product. It was the same with the other wavelengths that we're using currently. This also took some time to develop. And this is then a period of development which can take, you don't know really, it could take 5 years, 8 years, that's open, that depends. So we hope, for us, I think we hope that does move faster, but yeah, we can't drive that ourselves.
Okay, that's a little bit a pity, but coming to the chemistry side, so what is the specialty in the LED ink, Andreas?
So if you look at the designing of an ink, I think that the big challenge is you have to know that the maximum absorption of the common photoinitiator is different from the maximum emission of the current LEDs.
Okay.
That means having the raw material choice at the moment, you have to design a very reactive ink system, which also then you have to implement or to introduce a lot of photoinitiators to make it reactive enough, which can sometimes increase the pricing and also can create some migration issues. So at the moment, using the common raw materials, there are some challenges, but we hope also that the raw material manufacturer are developing new materials which can help us to design more efficient inks. And we are in close contact with them and also supporting these developments.
Okay, okay. What about Sun Chemicals?
Well, as it was said, we all take in raw materials from the same pool, and there is a limited number of photoinitiators that absorb in this area, and we have to compensate the lower wavelength or the lack of the lower or shorter wavelength energy with additional photoinitiator. So this is a reality, and that can create issues, especially if you want to print very fast, if you want to print migration compliant. And yeah, this is the situation. We all hope for new raw materials. However, we have to always remember that the current LED technology does not have UVC or UVB wavelength, and the wavelength currently offered is in the visible area. That means that all photoinitiators, the current ones or new ones that will be developed, are all yellow. And that creates a challenge, especially for clear systems like coatings and things like that.
Within the IST group, we are discussing multi-wave LED solutions. Might that be a really good potential for the future?
Well, again, it's a question where what wavelength areas we are talking about. The current commercial lamps only offer 365 to 405 nanometers. For us as a ink supplier, we formulate the same way for a lamp that offers 365 or 395. It's the same formulation. We have the same challenges. As soon as we talk about LED UVB systems or UVC systems, even from 278 to 310 nanometers, then it would open up a whole new area for us to work with.
Is that the same with Zeller and Gmelin?
I agree on that. As mentioned, if you would have these multi-wave systems, and we could also get at the lower end, let's say smaller than 300 nanometers wavelength, then we could use the existing raw materials. We would get very good depth curing and as well surface curing. And this would make the life of ink manufacturers much easier. So we are looking forward to get this.
Okay, very nice. We noticed that the usage of LEDs within the Asian area is much higher than or compared to the European countries and also North America. What would be the reason for that?
I think you have to differentiate that between the printing technologies. A good example is inkjet technology. For example, the Chinese manufacturers, they came quite late with their machines in comparison to North America, Japan, and Europe. But they started immediately with LED, so there was no question. And they're very quick in testing new technologies, introducing new technologies. They're also a little bit crazy for new technologies, and I think this is driving very much these innovations. And yeah, they are just faster than we are. And that's the reason for that. And I think it's similar to the sheet-fed commercial printing segment. I think the majority of machines going to China, for example, in commercial printing, they are now equipped with LED already. So I think it's a mentality question and also a question of at what time you enter a market.
Do you have this same?
Yeah, I have the same view. It's a question of the application space where UV is integrated into the workflow, meaning in Asia early on, the Asian market had discovered that you have advantages using UV technology in the commercial printing area, which is the standard technology printing, and there they had large advantages seen in the UV technology, and they started out with LED technology in this field, while here in Europe it's more packaging market driven, the UV technology, and therefore the LED systems did not offer a one-to-one replacement for the existing UV lamps, and therefore it was more the discovery for UV technology in a completely different area than it was for the Asian markets.
Thank you very much. So there's still room for the UV lamp. What are the advantages, basically, of an UV lamp compared to an LED system, Joachim?
So first of all, the fact is that the majority of our customers are using UV lamps. The big advantage is, first of all, it's a well-known technology, but also the availability of the chemistry, of the inks, of the coatings, and kind of the ease of use. But specifically that the high power, we mentioned that if you really need high power, it's giving it more of that. So, so it's well established. But as soon as we get into other features of LED, that might change. We are not there yet. Therefore, the advantages are really strong at this time of lamp.
Do you have the same reasoning behind that?
Yeah, I think that's perfect explanation of it. Yeah.
Okay. When it comes, within 10 years, where do we stand with an LED environment? Do every company use LED systems when it comes to UV curing? And what do you think, Holly?
I think we've discussed a lot about how there is still room for UV, and there always will be, but we don't know how it's going to go with the regulations in the future. In 10 years' time, there could be an issue. So for me, the most important thing is that LED goes further into more and more applications. And I think we've seen that now. LED is not only a trend now, it's here to stay. We heard yesterday from an end user. And so that's the main point. We've reached the tipping point. We're over the threshold, and we just need to keep going and keep pushing the technology further.
So Andreas, what's your assumption leading into the LED?
So for me, I think that the main driver will be the sustainable benefits. I think this will drive this technology, ozone-free, mercury-free, low energy consumption. And just taking into account that this technology is quite new, it's quite young, I think that the further development of this technology, as we heard, multi-wave, will also accelerate this transition. So I'm pretty sure in 10 years, the majority will use LED technology.
Do you agree here?
Absolutely, I absolutely agree. The technology will go on a strive, especially for applications that do not include compliant printing. For the time being. However, if there are developments for smaller wavelengths or shorter wavelength technologies, then we will see a much faster transition to the more sustainable LED lamps.
Thank you very much. And finally, Joachim, in 10 years, everything shifted to LED?
Difficult one. No, not everything. For me, it really depends on also the situation of the LED technology. If we can get in the market a low wavelength LED, we have a quick shift towards LED. If this will take time, long time, then it may be slower. But the clear answer is the tendency towards LED is there, and it's going on. The speed, let's see.
Okay, so we're finally at the end. Thank you very much. It was a pleasure to have you here and talk about the game-changing situation of the LED systems and also within the next 10 years. Yeah, so I'm handing over to Maxi and wish you all a very nice day and thank you for joining.
So thank you very much for these engaging words and for these insights.